Thank you. It's a pleasure to be with you here. It's 5 a.m. here in Rio, so let's make this interesting. So I myself can be woke up with you guys. I'm going to present today the experience of a work we are doing in partnership with NASA, with Talia Kirschbaum and her team. I'm sure you know Talia Kirschbaum. I'm a geographer working in the Rio de Janeiro city government. I currently serve there as city information director. We use a lot of GIS tools in this work, remote sensing, and well, let's go on. The idea is that we do have a partnership with NASA since the year of 2015. As part of this partnership, we are working with these overarching objectives. I would highlight the second one, pioneering applications of NASA observation at the urban scale. So it's a work really focused in the transition between the global scale that NASA does a lot and the local scale that is the most relevant for a city like us. We work with climate change, we work with air quality, we work with several areas, but most of our work most of our work is in the disasters area. We'll highlight today the work with landslides, but we do also work with flooding, urban flooding. So the idea is that we are integrating a local version of the LHASA model, still the first version of the LHASA model, developed by NASA within our framework of alerts and the EU Operational Center. Again, as you can see below, the idea is this transition between the global and the local scale. As most of you must know, NASA has this GPM mission, which allows us to have a global view of precipitation. And from this mission, you have several products like the LHASA model. It's a quite international effort to have this data. And this is like the global context, right? The local context that we have in Rio since 2010, the Rio Operation Center. It looks like a NASA control room, if you like. And it operates 24 hours a day, 7 days a week. It's a routine city operational center, but also really focused on dealing with crisis and with weather-related crisis. We have there the LHASA Rio, which is our MET office, I could say. This is linked to our geotechnical foundation. Rio is a city which deals with landslides for a long time, and we have since the 1960s a geotechnical foundation within the city government, which for Brazil is quite a unique situation due to the importance of the topic of landslides for the city. In the year of 2018, we launched at the control room of the Rio Operation Center our localized version of the LHASA, the global landslide model developed by NASA. I will explain to you briefly what is this. Yes, also most of you know that the landslide hazard assessment for situational awareness model. It operates with nowcasts, and it basically is will ingest GPM data from rainfall. As you can see here, it's an old version, but you can see here, and also a global landslide susceptibility map. It's very interesting. We found it to be relevant for what we saw in the city, but it could not, due to its temporal and spatial resolution, it could not be made operational within our operation center and our operational routine in such a local scale. It has a 1 kilometer spatial resolution for the susceptibility map, for example. And I guess the latency for the rainfall data is around 3 hours. So the latency for the model is also 3 hours. In a city like Rio, to be operational, you have to be obviously really fast, and it's a normal difference working with global and local realities and data. You are talking here about a model that is for situational awareness, and we wanted to move to a model for our operational use. So what we did was basically we got the Python script that LHASA is based on, and we ingested it into our GIS infrastructure, adapting it to run within it, and also to change the input data in some parameters. So for example, the city of Rio has 33 rain gauges distributed across the city, as you can see the map in the right. So we are using the data from these 33 rain gauges instead of GPM satellite data. This allows us to have a 5 minutes update interval. Basically, we have new rain gauge data every 5 minutes. We also are we changed the rainfall triggers. We have decades of study from this geotechnical foundation defining locally relevant rainfall triggers thresholds for landslide activation. So Rio, we basically have landslides caused by rainfall, which is our reality here. And we also changed the susceptibility map for a local map that we did already have, which is a map with 5 meters of spatial resolution. So you can see we gained a lot in terms of spatial and temporal resolution running a local version of the LHASA model. And this was released. So, and then you can see this is distributed to users in the form of a WebGIS tool based in ArcGIS Enterprise, our WebGIS environment from the city government. You can see some screenshots here of it running. And as you can see here, I didn't explain really how the LHASA model works, but I guess most of you know it. It will interact the rainfall data with the susceptibility data, and it will generate an nowcast of hazards, high hazard, moderate hazard, or no hazards, or no nowcast. Basically, that's it. So you can see here some screenshots in our WebGIS tool. You can also generate a retroactive analysis, so you can simulate how the model would be running for a specific day. It would be a summary of the day in this case here. In this case, is one of the worst scenarios we faced in Rio. Okay, you can interact with other relevant WebGIS layers, like what we call the support points for that people should go to in case of alarms, the areas for high risk of landslides, for example. You can see also the whole history of nowcasts that were issued by the model. This is basically the first version we have that was launched in 2018. I will do a short timeline of the project. So in the start of 2000, in the end of 2015, we started the partnership. In the end of 2016, we did a workshop in New York with NASA, where we decided to move on with the LHASA, local LHASA project. Okay, we launched the model, the first version of it, in September 2018. Okay, we have in our summer in the southern hemisphere, in our winter, we had a test phase for the LHASA in the summer 2018-2019. And after that, we did a workshop in October 2019, where we could assess the results of the model. And we gained confidence in moving forward with it for our operational use. I will show you why. Okay, and then we started using the model operationally in the summer plan 2019-2020, but it's still more like for information, for situational awareness, and gaining confidence of the users. Okay. And we did some new implementations for January 2020 based on user feedback. I will briefly show you that. And now the model is part of the city's operational protocols. Okay, and now we have ongoing new scripts for exposure assessment, and also we are assessing the viability of working with weather forecasts. In Rio, weather forecast is quite complex and to be precise, so we are assessing that and which model should we use and so So we did a validation test for the LHASA Rio model for the two major rain events that we have since the model was released, and those were in the summer, in the wet season of 2018 to 2019, okay? And we had almost 88% hit rate, meaning that of the 219 landslides that we mapped using local data, using satellites, we found that 192 were in areas that LHASA Rio was mapping, was issuing nowcasts. Okay. Based on user feedback, we added 2 new hazard levels and basically 1 new set of rainfall triggers, because we had one set of rainfall triggers, which was like yes or no. And the users wanted to be able to rank, to prioritize different levels of hazards. So basically we are assessing hazard, right? And we added this new high, this new critical rainfall trigger. So with that and interacting with the susceptibility map, we started having basically four levels of hazards. This was already due to user feedback. So now we are working with exposure and the possibility of having a forecast also component, part of this overall LHASA 2.0 project, okay, that we are with NASA, with Talia's team. And this, you can see here, one dashboard, which we are running in a test phase, which is showing for a specific area that you can see the nowcast below. You can see the streets above. So the streets are being classified based on the hazard level and the rainfall they are facing. And this is the desktop version of the model, of the web app.
Go to the conclusions, Felipe.
Okay, thank you. I'm almost finished. And here you can see the mobile version of the web app to see the results. Basically, you are seeing here the streets that are in an area with hazard. You can see the rainfall for that segment of that street, and you can filter out. So you can filter only what we call structural streets, or the most important roads in the city. Or you can filter for, there are 5 different hierarchy levels of streets in Rio. So you can filter based on that, all those 5 levels of hierarchy to see which are the streets that are facing hazard. And this is very important since the city has protocols to close certain streets in a scenario where there is hazard for landslides. And this is done manually today, and we want to automatically to automatize the decision making of you have to close this street or that street and so on. We are also studying an application for what we are calling mobile siren, which is you have in the city of Rio some stationary physical sirens in areas with high risk of landslides, but this does not cover the whole city. The idea is that the user can have in its smartphone, our operation center has an app, and it can ring, it can give a very loud or whatever notification if that person is in a place based on GPS, is in a place with hazard for landslides, and you can give them instructions on how to be safe. I guess basically that's all. It's a pleasure to be with you guys here. This is also the work of a team and highlighting the partnership with NASA. Also, thank you.
Of course, thank you very much.